Noche Cósmica.
Imagine standing in a room so large that the nearest wall is farther away than the distance between the Earth and the Sun. That wall is still invisible. That wall has always been invisible, and it will remain invisible for the rest of your life, even if you could walk toward it at the speed of light. This is not hyperbole. This is what space actually is. We do not live in a universe crowded with stuff. We live in a universe that is, by almost any measure that matters, fundamentally and profoundly empty. Empty in a way that our minds struggle to hold, because we spend our entire lives surrounded by density, by air thick enough to move through, by objects pressing against other objects, by the constant friction of matter against matter. Space, by contrast, is silence. Space is the opposite of crowding. Space is what remains when you remove almost everything. The great astronomer Carl Sagan once said that the universe is a pretty big place. That is, perhaps, the gentlest understatement ever made. And the reason it feels so incomprehensibly large is precisely because it contains so very little. If you're drawn to the strange comfort of these ideas, to journeys through the quiet vastness between worlds, to the kind of peace that comes from understanding just how much nothing exists between the things we see, consider subscribing. We'll venture together through stretches of space so empty that light itself seems to move through them reluctantly, exploring why the universe is designed almost entirely as an absence rather than a presence. For now, settle into this thought. Picture yourself drifting. You are suspended in the darkness between two stars, not inside a spaceship, not protected by walls or metal or anything resembling shelter, just there, drifting through the void that separates our sun from its nearest neighbor, Proxima Centauri. The silence around you is total. It is not the silence of a quiet room, because even the quietest room on Earth contains sound. The hum of electricity, the gentle percussion of your own heartbeat, the whisper of air moving through space. This is different. This is the silence of a place where sound cannot exist, because there is nothing to carry it, no atmosphere, no molecules banging into one another, just the slow, patient drift of your body through an emptiness so complete that it takes on an almost physical quality, as if the nothing itself has become something you can feel. Above you, around you, in every direction you might turn your head, if you had anything to turn it toward, there is darkness. Not the warm darkness of night on Earth, where your eyes can eventually adjust and find the faint light of distant stars. Not the darkness of clouds or shadow. This darkness is absolute. It is the color of the space between the stars, and it is almost entirely black, because there is almost nothing here to reflect any light at all. Your nearest star, the one you came from, the sun that warmed countless generations of human faces, is now so far away that it appears as nothing more than the brightest point in the sky. Brighter than any other star, yes, but reduced to a pinpoint. All the light that star produces, all that tremendous energy that powers photosynthesis and warms the oceans and makes life possible, has been spread so thin across the distance that you would need to gather it for hours to notice any warmth on your skin. And ahead of you, in the direction you are drifting, lies another star. Proxima Centauri. It is the closest star to our sun in the entire Milky Way, the closest companion to our own star in this vast cosmic neighborhood. Yet it will take you more than 30,000 years to reach it, traveling at the speed of light. 30,000 years. The entire recorded history of human civilization is only about 5,000 years old. You would have to wait 6 times that span, drifting silently through absolute emptiness before you arrived anywhere that might be described as a destination. And in all that journey, in those 30,000 years of travel, what would you encounter? What would pass by your drifting form? Essentially nothing, perhaps a few stray atoms, the faint whisper of particles carried on the solar wind. Occasional grains of dust, so sparse and scattered that you could pass through millions of cubic miles of space and never collide with anything solid. Never. The likelihood of hitting anything, of encountering a piece of rock or ice or any object larger than a grain of sand, is so astronomically small that we would need new mathematics to properly express how unlikely it would be. This is the paradox we will explore together through the darkness of this night. Space is, quite literally, almost completely empty, and yet it is not quite empty. It is not the mathematical zero of perfect vacuum. Even the darkest places between stars contain something, a few hydrogen atoms here, the faintest trace of a magnetic field there, the patient trickle of ancient light that began its journey billions of years ago. These touches of matter and energy are so thin, so scattered, so utterly negligible that they barely register as existing at all. And yet, they are what makes the universe possible. Think of it this way. If all of space were the ocean, the stars would be individual grains of sand, not beaches of sand, not even piles of sand, single grains, scattered across an infinite shoreline, separated by oceans of water so vast that a grain might travel through 10 million cubic miles of ocean before encountering another grain. The emptiness is not just vast, it is the dominant feature. Emptiness is the ocean. Everything else, all the stars, all the planets, all the galaxies in the known universe, is the sparse seasoning sprinkled across that emptiness. As you drift through this interstellar gulf, you might begin to feel the weight of that realization. Space is not a place you travel through on the way to somewhere else. Space is not the background against which cosmic events occur. Space, fundamentally, is the thing itself. Space is what the universe is made of. Matter, all the solid, tangible stuff we can see and touch and measure, is the exception. It is what briefly interrupts the emptiness. It is the aberration in a cosmos designed almost entirely as an absence. Your body, drifting in this darkness, is itself an exception. The atoms that make up your skin, your bones, your blood, they are so densely packed that they seem solid, that they seem to occupy space in a way that matters. But even your body is mostly empty. Even the atoms that compose you are mostly empty space. An atom is like a solar system in miniature, a nucleus at the center, electrons orbiting at an almost unimaginable distance relative to the size of the nucleus itself. If you could remove all the empty space from an atom, shrink it down to just the hard matter, the atom would be perhaps 1 billion times smaller than it actually is. If you could do this for every atom in your body, your entire physical form would shrink to the size of a grain of sand. So you are drifting, as a being almost entirely made of nothing, through a realm that is almost entirely made of nothing, moving toward a distant star that represents an almost impossibly small concentration of matter in the vast cosmic sea of emptiness. This is not a journey you are actually taking, but it is, in many ways, the journey we are all taking simply by existing. We are all drifting through space. The Earth drifts, the Sun drifts, the galaxies drift. Everything is in motion through an emptiness so profound that it takes on a quality beyond mere absence. As you float there in that imagined darkness, moving silently through the gulf between two stars, you might notice something unexpected beginning to happen. That absolute silence starts to sound, somehow, like peace. That total darkness starts to feel, in a way that is difficult to explain, like rest. The emptiness that seemed so alien, so hostile, so utterly opposed to the fullness of life you know on Earth, begins to feel like it might be the most natural thing in the universe. Because it is. It is the most natural thing. Everything else, every star, every planet, every spark of life, is the mystery. The emptiness is simply what is. And as you drift further into this profound silence, suspended in the knowledge that almost nothing occupies the space between worlds, you might find yourself wondering what other mysteries unfold in these quiet reaches. If this journey through the emptiness calls to you, if you find solace in contemplating the vast architecture of nothing that allows everything to exist, you're invited to return to these explorations. There are depths of cosmic silence yet to traverse, worlds of understanding waiting in the gentle dark, and future passages through the void where we'll examine not just the empty space itself, but what that emptiness means for light, for gravity, for the possibility of life itself. Each journey builds, layer upon layer, revealing how our universe's structure emerges from its fundamental sparseness. For now, though, let us continue deeper still into the spaces you've already begun to understand. The silence around you is not barren. It contains stories, physics, and the architecture of existence itself. And as we move forward together through this exploration, you'll find that what seems like nothing is actually the canvas upon which everything is drawn. The scale that unfolds before us requires a kind of mental recalibration, a gentle shifting of perspective that helps us grasp distances so immense they strain the ordinary imagination. Picture, if you will, the moon and the earth. These two celestial companions seem bound together, orbiting in an intimate dance across our night sky. And yet between them lies a void of nearly 400,000 kilometers. That distance is so large that you could fit more than 30 Earths placed side by side along that single gap. 30 worlds of forests and oceans and mountains. And yet from space, from the perspective of a distant observer, this separation appears almost as nothing. The Earth and Moon seem to touch, to orbit one another in a quiet embrace. But expand your view now. Place the Sun into this picture. The Sun, that great furnace around which all our worlds revolve, sits at a distance from the Earth of roughly 150 million kilometers. This is what we call an astronomical unit, a measuring stick we've created precisely because the old measurements fail us at these scales. Kilometers become inadequate. They reduce the incomprehensible to mere numbers. But consider what this truly means. The distance from the Earth to the Sun is roughly 400 times the distance from the Earth to the Moon. In other words, you could line up 400 Moon-Earth journeys end to end, and only then would you traverse the space between our world and the star that makes life possible. And between the Earth and Sun, in that immense gulf, floats almost nothing at all. Not the Moon, which orbits far closer to us. Not Venus or Mercury, which follow their own paths. The space itself is nearly perfect emptiness, a medium so thin that light takes 8 minutes and 20 seconds to cross it, a journey that seems instantaneous to our earthbound perception, yet speaks volumes about the distances involved. For 8 minutes, photons travel through a void so sparse, so nearly devoid of matter, that if you collected all the air molecules in a room, all that breath and atmosphere, and distributed them evenly across the space between Earth and Sun, the result would be less dense than the finest laboratory vacuum we've ever created. This is the first glimpse of the emptiness, and already it reshapes how we understand our home. The worlds we inhabit, the planets that share our solar system, are not crammed together. They are islands, separated by gulfs of nothing, held in their orbits by the invisible geometry of gravity and the vast emptiness that surrounds them. Now, let us begin with something you already know, yet perhaps have never truly felt. The moon hangs above us, that pale and faithful companion, and it seems so close that one might imagine stepping toward it across a bridge of air. And yet between your feet and that luminous disk lies a distance of some 384,000 kilometers. Imagine laying down a line of human bodies, head to toe, across that emptiness. It would take nearly 10 billion people, stretched in a column through the black, just to span that gap. The Moon, our nearest neighbor in space, is already so distant that light itself takes more than a full second to make the journey there and back. But the Moon is merely the first whisper of distance. The Sun, that warm and vital sphere from which all our warmth and light derives, orbits at a much greater remove. 150 million kilometers separate us from that furnace. If we were to shrink the Earth down to the size of a grain of sand, the Sun would still be a considerable sphere, yet the space between them would stretch across a football field. Most people carry an intuition that the solar system is somehow a cozy gathering of worlds, clustered together for safety and company. The truth is gentler and stranger. It is an archipelago scattered across an ocean of nothing. Think of it this way, and perhaps the scale will settle into your mind more easily. If we were to compress the Earth down to the size of a peppercorn, the Moon would be an even tinier fleck, orbiting at a distance of about 30 centimeters away. And the Sun would be a grapefruit, positioned some 15 meters distant. In that model, the entire inner solar system, the region where we live, where water exists in liquid form, where all of human history has unfolded, occupies a space no larger than a modest house. The rest of the solar system extends far beyond, and yet even that vast region remains, in cosmic terms, almost unbearably sparse. What we are learning, in these opening moments, is that space between things is not an accident. It is the dominant feature of the universe. Empty space is not a mistake that the cosmos must apologize for. It is the canvas upon which all structure is painted, the silence in which all sound can be heard. Between Earth and Moon lies not only distance, but possibility. The void is what allows the Moon to remain separate from us, to maintain its own world, its own mountains and valleys, and the subtle pull of gravity that moves our tides. Without that intervening emptiness, the two worlds would have collided eons ago, merging into some new and featureless sphere. And consider too what that emptiness contains, or rather, does not contain. If you were to travel through the space between the Earth and Moon, you would encounter almost no obstacles. A few solar wind particles perhaps, wisps of electrically charged gas flowing outward from the Sun, a stray cosmic ray now and then, a high-energy particle from some distant supernova. But the overwhelming impression would be one of profound solitude. The pressure would be lower than we can create in our finest laboratory vacuums. The temperature would hover just a few degrees above absolute zero. And yet, even in that apparent nothingness, there would be something, not nothing, but nearly nothing. Not a void that is truly void, but a thinness so extreme that it approaches the limit of thinness itself. This is the first lesson the cosmos teaches us about emptiness. It is vast beyond intuition, it is profound beyond emotion, and it has always been this way. The universe has never been crowded. Even in the moment of its birth, even when all matter and energy were compressed into that initial point of infinite density, space itself was already infinite, already everywhere and nowhere at once. When that first expansion began, in what we call the Big Bang, it did not create emptiness, it filled emptiness. It stretched itself across the void like a whisper spreading through darkness, never quite filling it, never quite reaching the edges, because the void has no edges and cannot truly be filled. So we begin our journey with these humble distances, from Earth to Moon, from Earth to Sun, as anchors, as reference points. These are the scales against which we can begin to measure something much larger. For if such immense distances separate us from our nearest cosmic neighbors, what awaits us as we venture further outward, into the spaces between planets, between stars, between worlds we have not yet even begun to imagine? Now, imagine stepping back from those three celestial neighbors, Earth, Moon, and Sun, and allowing your perspective to widen outward, the way a camera pulls away from a landscape to reveal the true shape of the land. The solar system spreads before you, a family of 8 major planets, each in its own vast orbit, each separated by distances so profoundly empty that the word separation hardly does them justice. Between Mercury and Venus, between Venus and Earth, between Earth and Mars, there exists nothing. No clouds, no dust, no whisper of air, just the pure black of space, measured in millions of kilometers, waiting in patient silence. Mercury, that small heat-scorched world closest to the Sun, orbits at a distance of about 58 million kilometers. Venus, our sister planet with its crushing atmosphere, floats at around 108 million kilometers away. Earth, of course, sits at our familiar 150 million kilometers, the distance we call an astronomical unit, or AU, a yardstick we've created simply because the gap is so profound we needed a name for it. Between these 3 inner worlds lies an almost incomprehensible void. If you were to somehow place them in a room, to see them all at once without the terrible distance between them, they would seem almost clustered, almost neighborly. But space will not allow such intimacy. Space insists on separation. Space demands emptiness. And then there is Mars, that rust-colored world that has captivated human imagination for centuries, hanging in its orbit somewhere beyond Earth's path. To reach Mars from our home, a spacecraft must travel across a gulf that shrinks and swells with the dance of orbital mechanics. At its closest approach, Mars draws within 54 million kilometers of Earth. At its most distant, the separation stretches to as much as 400 million kilometers. That variation alone, that breathing rhythm of cosmic distance, tells you something profound about the nature of the solar system. These worlds are not fixed in place. They move. They waltz around the sun in their prescribed paths, and the spaces between them expand and contract like the chest of a sleeping giant. Beyond Mars, the emptiness deepens. The asteroid belt, that region between the orbits of Mars and Jupiter that so many popular imaginings have crowded with tumbling rocks and metallic dust, is actually far more silent and sparse than most people ever imagine. We will speak more of that deception in a moment, but for now, simply know that even in that supposed region of density, there exists vastness. Emptiness upon emptiness, and then Jupiter arrives, a world so enormous, a gas giant so swollen with storms and radiation, that it sits at a distance of roughly 775 million kilometers from the Sun, nearly 5 times farther than Earth's own orbit. The light from the Sun, which reaches your face in 8 minutes, takes more than 4 times that duration to illuminate Jupiter's turbulent clouds. Consider what that means. Between Mars and Jupiter, between the inner solar system and the realm of the gas giants, there stretches a gap so immense that a spacecraft must coast through it for years, an ocean of nothingness, punctuated by the rare tumble of a small rock. The silence between these worlds is not merely the absence of sound. Sound cannot travel in the vacuum, cannot propagate through nothing, but rather the absence of presence itself. If you were to float in that gulf between Mars and Jupiter, you would be suspended in absolute solitude. No nearby world would be visible to the naked eye. The sun would appear as merely the brightest star in an otherwise unremarkable sky. The inner planets would have retreated beyond the ability of sight. You would be utterly, profoundly alone. And yet, Jupiter itself is not the end. Beyond it lies Saturn, beautiful Saturn with its gossamer rings, orbiting at distances that stretch to over 1 billion kilometers from the Sun. Uranus moves through its solitary path at a distance nearly twice that. Neptune, that deep blue world at the edge of what we call the planetary region, dwells in twilight at nearly 3 billion kilometers away. The light that illuminates Neptune has traveled for more than 4 hours in darkness to reach it. 4 hours of emptiness, of void, of space with no feature, no landmark, nothing to catch the eye, or mark the passage of time. What becomes apparent, as you allow this widening perspective to settle into your mind, is that the planets themselves, those 8 bodies that we have named and mapped and characterized and loved, are essentially isolated points, scattered through an ocean of blackness. They are not a system in the sense of being clustered or close together. They are a system only in the sense that they share a common origin and a shared star. Gravity binds them. The sun's pull holds them in their orbits. But the distances between them are so vast, so fundamentally overwhelming, that if you were to measure them on any human scale, even on the scale of Earth itself, they would seem impossibly far apart. They are, in truth, lonelier than most of us ever fully contemplate. And yet, when we speak of this emptiness, we use a word that carries profound misunderstanding in its simplest utterance. Empty. What does empty truly mean? Not the absence of everything, but rather the absence of what matters to us. The absence, perhaps, of what we can touch and hold and feel pushing back against our bodies. In the language of physics, empty space is called a vacuum, and a vacuum is never, ever, truly nothing at all. Consider the air around you in this moment, the breath you have just drawn. In that single breath, roughly 3 sextillion molecules dance and collide and compress around your lungs. 3 followed by 21 zeros. That is not emptiness. That is a crowded metropolis at molecular scale. Now imagine removing 99% of those molecules, then 99% again, then again and again, until nearly nothing remains. What you arrive at is closer to what space itself contains, yet it is still not nothing. It is a profound distinction, one that changes everything about how we understand what surrounds us. The vacuum of space, true vacuum as physicists understand it, is defined not by the absence of particles but by pressure. Pressure is simply the force exerted when molecules strike a surface. At sea level on Earth, the weight of our atmosphere presses down with the force of about 14 pounds per square inch. Move higher into the mountains, and that pressure drops. Fewer molecules means gentler crushing weight. Continue upward past the clouds, beyond where the smallest birds can fly, and the pressure becomes so slight it is almost negligible. But it is still there. Continue beyond the edge of our atmosphere entirely, into the space that begins only 100 kilometers above the Earth's surface, and something remarkable happens. The pressure does not reach zero. It never reaches zero. Instead, it drops to something almost incomprehensibly low, perhaps only a trillionth of what presses down upon you now. A single cubic centimeter of the near vacuum of low Earth orbit contains perhaps a few million atoms or molecules. Compare that to the same volume of air at sea level, which holds about 25 trillion billion molecules. The ratio is almost beyond intuition. It is the difference between a handful of people in a city of billions or a single grain of sand lost in an ocean that spans a continent. And this is remarkable. Even at this extraordinary thinness, space is not empty. Particles still exist. They are simply spread so far apart that the distance between one atom and its nearest neighbor is almost unimaginable. If an atom were the size of a marble placed in the middle of an empty football field, its nearest companion might rest somewhere in the next town over. The particles are there, but separated by voids so profound that an atom could travel at tremendous speed for years, perhaps centuries, without ever colliding with another. This is what physicists mean when they invoke the term vacuum. It is a state of extremely low pressure, not the presence of literally nothing. The vacuum of space is filled, and we might hear the gentleness in this paradox, filled with almost nothing, filled with emptiness itself, which is not the same as filled with objects. It is the presence of absence, an emptiness so profound that it becomes almost a substance in its own right. Why should this distinction matter to us? drifting as we imagine ourselves through the night, through these great gulfs between worlds, because it transforms what emptiness means. The space between the earth and moon is not a void that contains some air and some rocks and some stray particles. It is a void that contains, per unit volume, so few atoms that an object could pass through it for vast distances without meeting a single collision. It is empty in a way that earthly emptiness, an empty room, an empty desert, an empty ocean, can never be. Those earthly voids are crowded, bustling with molecules. And as we begin to push our imagination outward, past the moon and toward the sun, past the inner planets toward the distant reaches of the solar system, this vacuum deepens and thins further still. The pressure, already almost nothing, becomes something approaching the theoretical limit of true emptiness. Yet still, particles persist, scattered hydrogen atoms, lone electrons, wisps of solar wind streaming outward from the sun's corona like the gentlest breath imaginable. The universe does not give us literal nothing. It gives us something far more subtle, and almost nothing so profound that in its vastness it allows everything to breathe. Beyond Neptune's frozen orbit, where the sun's warmth becomes a distant whisper, lies one of the most misunderstood regions of our solar system. If you've ever seen an image of the asteroid belt, that dense band of rocks tumbling endlessly between Mars and Jupiter, you might imagine it as a perilous minefield, a cosmic shooting gallery where collisions happen constantly. But nothing could be further from the truth. The asteroid belt, despite its name, is far more empty than it is full. Consider the scale for a moment. The asteroid belt stretches across a region roughly 5 times wider than the distance from Earth to the Sun. Within this vast annular band, there are millions of rocky objects. And yet, if you were to travel through it in a spacecraft, you would likely pass for years without encountering a single fragment. The average distance between asteroids is not measured in millions of kilometers, but in many, many millions. There is more nothing than something, even here, where we might expect the densest clustering of debris left over from the solar system's formation. This disparity between expectation and reality owes much to how we visualize space through film and television. Hollywood compresses distances and populations for dramatic effect. An asteroid field becomes a thrilling obstacle course because narrative demands tension. But the actual asteroid belt is so sparse that planetary probes have drifted through it without incident. The risk of collision, statistically speaking, is negligible. A spacecraft crossing the belt would be far more likely to miss its targets than to find them. What asteroids are there do congregate in certain regions? The Kirkwood Gaps, for instance, where Jupiter's gravitational pull has long since cleared pathways, leaving emptier lanes within an already sparse field. It's a curious reminder that even within the asteroid belt's thin distribution, gravity continues to shape order, to carve channels and leave voids. The belt is not one continuous river of rock, but rather an archipelago of solitude, with vast chasms of absolute nothing separating individual worlds. And as you venture even deeper into the solar system, moving inward past the belt toward Jupiter itself, the sparseness continues. Yes, Jupiter has its Galilean moons, Io, Europa, Ganymede, Callisto, remarkable worlds that orbit the gas giant. But the space between them remains almost unimaginably large. These moons hang in the darkness like pearls on an invisible string, separated by distances that would take human spacecraft weeks or months to traverse. What connects them is not matter but gravity, a silent force working across void. This pattern repeats throughout the solar system. Saturn and its rings, for all their visual splendor, occupy a region that is predominantly empty. Even the rings themselves, those apparently solid bands of ice and dust, are composed of particles so widely spaced that if you were standing on one of them, the others would be invisible to the naked eye. They would appear as a thin, almost transparent veil, rather than a dense, crowded structure. The space between grains of ring material might be larger than the grains themselves. And then there is the space between the planets themselves. Mercury, Venus, Earth, Mars. These inner worlds are separated by millions of kilometers of near-perfect vacuum. Mars orbits at a distance roughly 1.5 times Earth's distance from the Sun. Between Mars and Jupiter, there's still more emptiness than complexity. The solar system, for all its clockwork precision and intricate orbits, is fundamentally a realm of isolation. Each world is an island. Each moon is a satellite drifting in profound solitude. What makes the asteroid belt so instructive in understanding why space is empty is that it represents the exception that proves the rule. It is, by comparison to most of space, relatively crowded, and yet it is still shockingly sparse. If you wanted to truly feel alone, surrounded by the physical remnants of planetary formation, yet utterly isolated from other matter, the asteroid belt would deliver that sensation perfectly. You could float through it for a lifetime without touching another object, without seeing anything but stars and the distant sun shrinking slowly in the cosmic distance. The human mind struggles with this concept because we are creatures of density. We live on a planet where matter is tightly packed, where you cannot walk more than a few meters without encountering another object. We evolved in an environment of substance, of collision and contact. But space, the asteroid belt reminds us, operates under entirely different rules. It is patient, hollow, indifferent to our expectations. And in that emptiness lies a strange kind of peace, a permission for isolated worlds to pursue their orbits uninterrupted, to exist in elegant solitude for billions of years. And yet, even in this profound isolation between the planetary spheres, the space that surrounds us is not entirely still. It is not quite as utterly barren as one might imagine from a distance. There is a whisper moving through the void, a slow, perpetual breath emanating from the sun itself, and it carries with it something almost like life, or at least the evidence of something living and dynamic at the heart of our solar system. This breath has a name. Scientists call it the solar wind, and it is one of the universe's most elegant paradoxes. Even as we acknowledge that space between the planets is nearly empty, we must also recognize that the sun is constantly sending forth streams of charged particles, electrons and protons, fragments of plasma, spreading outward in all directions at speeds around 400 kilometers per second. Imagine standing on the surface of a vast sphere of nuclear fusion, and from that sphere, a gentle but relentless current flows eternally outward, like the ripples from a stone dropped into still water, except these ripples never stop, never fade, never settle. The solar wind is sparse, it is true, extraordinarily sparse, where you might encounter trillions of molecules in a single cubic centimeter of air here on Earth. In the solar wind between the planets, you would find perhaps 5 or 10 protons per cubic centimeter. That is a density so low that on Earth we would call it an extraordinarily good laboratory vacuum, the kind that requires expensive equipment to create and maintain. And yet it is everywhere in our solar system, a constant, invisible presence, a whisper rather than a shout. This whisper carries consequences. The solar wind shapes the magnetospheres of planets, those invisible shells of magnetic protection that surround worlds like Earth. It streams past Mercury, past Venus, past our own world. It buffets the moons of Jupiter and Saturn. It reaches out beyond Neptune, gradually thinning but never truly ceasing, until eventually, in that vast outer halo of icy bodies and cosmic dust we call the Oort cloud, it meets the thin interstellar medium, the extremely sparse gas and dust that drifts between the stars themselves, and they merge into one another in a boundary so gradual that no sharp line divides them. The solar wind is a reminder that even in emptiness, even in the profound stillness of space, there is movement, there is flow, there is a kind of circulation, a cosmic breathing that connects the sun to the farthest reaches of its gravitational domain. For billions of years, it has been streaming outward in an unbroken current, carrying particles and energy and the signature of our sun into the darkness beyond. How can something so thin, so nearly invisible, possess any significance at all? And the answer reveals something profound about the nature of space itself. The solar wind does not need to be dense to matter. It only needs to be persistent. It only needs to be there, carrying charge and momentum for eons and eons. Over vast stretches of time, the gentlest of forces can shape worlds. The softest whisper, if it never stops, becomes a voice that resonates through an entire planetary system. Between the planetary orbits, then, the void is not a perfect emptiness. It is a space filled with absence, vast, profound, almost incomprehensible in its lack of density, and yet inhabited by this solar wind, this thin stream of particles and energy that connects the sun to everything that orbits around it. The planets themselves hang in this wind like islands in a current, each one surrounded by an ocean of nothing, and yet touched constantly by this invisible breath. How strange it is to consider that the space you occupy right now, here on Earth, is being filled by particles that began their journey at the surface of the sun 8 minutes ago. Light from the sun reaches you in that same time, but the solar wind, slower and more patient, takes days or weeks to arrive, depending on its speed. And the very faintest particles, the slowest travelers, take even longer, drifting through the darkness until they reach the outer planets or the distant reaches of space beyond. This is the paradox of interplanetary space. It is empty, yes, profoundly, almost impossibly empty, and yet it is not silent, it is not truly still. It carries within it a constant, gentle circulation, a perpetual flow of particles and energy that connects the sun to its realm. The void itself breathes, the emptiness itself moves, and in that movement, in that whisper that has been speaking since the sun first ignited, there is a kind of order, a kind of structure, even in the heart of the vast and terrible nothing that separates the worlds. Beyond the solar system's outer reaches, where Pluto's orbit traces its distant ellipse, something profound shifts in the nature of emptiness itself. The sun's gravitational influence, which still holds the farthest icy bodies in its ancient grip, begins to fade. And in that transition, you cross a threshold that few have yet traveled, though many have imagined it in the quiet hours before sleep. You are now moving into interstellar space, the genuine void between stars. The nearest star to our sun is Proxima Centauri, a small, dim red dwarf that has been humanity's closest stellar neighbor for at least 30,000 years. It lies at a distance of 4.24 light-years. Pause with that number for a moment. Light itself, traveling at 186,000 miles per second, the fastest thing we know, requires 4.24 years to cross from one star to the other. To place this in a scale your mind can hold, if the Earth were the size of a grain of sand, the sun would be a marble sitting roughly 1 meter away. The moon would be a speck of dust orbiting that marble, and Proxima Centauri would be another marble located 40 kilometers distant, 400 times farther than the sun itself. The emptiness between them is not merely vast, it is almost incomprehensibly deep. Consider what that distance means for the particles themselves. The radiation that leaves Proxima Centauri's surface, the photons that carry its light across the interstellar gulf, encounters almost nothing on their journey. A few stray atoms, perhaps a grain or two of dust, microscopically thin. The same is true for anything that might travel between these two suns. A spacecraft, traveling at the fastest speed humanity has yet achieved, would require over 80,000 years to cross from our Sun to Proxima Centauri. The engineer and the traveler would both age into dust themselves before the journey ended. Time itself becomes almost as vast a gulf as space. Yet Proxima Centauri is not alone. Beyond it lies Sirius, at 8.6 light-years away. Beyond Sirius lies Vega. Beyond Vega, an ever-expanding shell of stars, each separated from its neighbors by light-years of genuine emptiness. The nearest 10 stars to Earth are scattered across a bubble of space approximately 80 light-years across, and between each pair lies a profound silence. If you were to map this region with perfect accuracy, plotting every atom, every photon, every whisper of radiation between these neighboring suns, you would find that the space between them is so empty that it makes the solar system, by comparison, seem almost crowded. What sustains the emptiness of interstellar space is precisely what made the earlier voids so profound: the weakness of gravity at distance, and the fact that atoms repel one another at very close range. The Sun does not extend its gravity infinitely. At the distance of Proxima Centauri, the solar gravitational pull has weakened so dramatically that it is almost negligible. The same is true of Proxima's gravity pulling on our solar system. Each star inhabits its own sphere of influence, and between those spheres lies the vast domain of nothing. Yet even as you contemplate this emptiness, something subtle occurs. Your imagination may have painted interstellar space as absolute vacuum, but it is not quite that. Between the stars flows what astronomers call the interstellar medium, a gossamer-thin mixture of gas and dust. This medium is so sparse that if you collected all the atoms in a volume the size of Earth itself, you would hold less matter than a single grain of sand. It is emptier than any laboratory vacuum humans have created on the surface of the world, and yet it is not quite nothing. It is something. Hydrogen atoms drift through this space, mostly alone, occasionally finding partners to form molecules. Helium atoms move through the silence. Dust grains, particles of silicon and carbon, no larger than a micrometer, travel their slow paths. And starlight, filtering through billions of miles of darkness, illuminates these particles in ways that create the soft nebulae visible from Earth on clear nights. The emptiness, in other words, possesses a texture. It has character. It is a canvas upon which light and gravity will eventually paint stars and galaxies and the structures that allow for life itself. The question that may now arise in your mind, as you drift deeper into the silence of interstellar space, is how anything ever comes together at all in such emptiness. How do new stars form when the material is so impossibly sparse? The answer lies in the vast stretches of time that the universe provides. What seems empty on human timescales, emptiness measured in decades or centuries, is actually a reservoir of slow, patient processes. Gravity works across millions of years. Collisions accumulate. Dust grains stick together, grain by grain, until they form pebbles. Pebbles cluster into boulders. Boulders merge into larger and larger bodies. In the patient, unrushed vastness of interstellar space, emptiness itself becomes pregnant with possibility. And yet, even in the emptiness between stars, space is not entirely silent. Within those vast gulfs of nothingness floats the interstellar medium, a gossamer veil of gas and dust, so thin that it barely whispers of its own existence. Yet it is here, in these sparse clouds, that some of the most profound transformations in the cosmos unfold. The atoms that will one day become new worlds and new suns drift in this medium now, patient and cold, waiting for the slow hand of gravity to gather them together. Picture, if you will, a single breath exhaled into an auditorium the size of a city. That is roughly the density of the interstellar medium in many places, so dilute that our finest laboratory vacuums on Earth are actually far denser than the space between the stars. And yet this gossamer thinness is deceptive. These clouds are not uniformly spread across the galaxy. They gather in regions, drawn together by the subtle pull of gravity across millions of years, creating pockets of slightly greater concentration. Hydrogen atoms, the most abundant element in the universe, cluster loosely with helium and heavier elements, carbon, nitrogen, oxygen, iron, forged long ago in the hearts of dying stars and now scattered through space like ashes from an ancient fire. Within some of these clouds, the concentration grows just dense enough that the slightest gravitational advantage begins to matter. A region where atoms cluster a little more thickly than its surroundings exerts a faint pull on its neighbors. More atoms fall inward. The pull strengthens, the collapse accelerates, though still on timescales that make human patience seem trivial, hundreds of thousands of years passing as quietly as a held breath. The cloud begins to spiral inward, rotating faster as it shrinks, like ice skaters drawing their arms close to their bodies. Dust grains, microscopic particles of carbon and silicates born from stellar furnaces, swirl through the contracting cloud, and as they collide and stick, they begin to warm. This is how stars are born from emptiness. The very sparseness of space makes this process possible, for if the interstellar medium were denser, the pressure pushing outward would resist the inward pull of gravity. It is the near vacuum that allows gravity to win. In the heart of a collapsing cloud, the material grows denser and hotter still, temperatures rising from near absolute zero to thousands of degrees, until the pressure and heat at the core reach a threshold. Hydrogen atoms begin to fuse together, releasing titanic energy, and a star ignites in the darkness. Around many of these newborn stars, a disk of dust and gas persists, a thin, flat pancake of material orbiting the young sun. Within this disk, grains of dust collide and adhere, building up into pebbles, then boulders, then larger and larger bodies. Planets form from the sparse material, their birth a monument to the slow work of gravity in the emptiness. Earth itself was once just such a gathering of cosmic dust, born from the collapse of a cloud in the interstellar medium around our own young sun, billions of years ago. The interstellar medium itself is not uniform. Vast bubbles of tenuous gas, heated by the radiation from nearby young stars, push outward and create hollows, regions even emptier than their surroundings. The shells of these bubbles compress the material beyond them, sometimes triggering new collapses, new generations of star formation. It is almost a paradox, is it not? The emptiness creates the conditions for creation. The very thinness of space allows gravity to work its patient sculpture, drawing matter together into structures of stunning complexity. Some of these interstellar clouds carry names that hint at their role in cosmic birth: the Orion Nebula, the Crab Nebula, the Eagle Nebula, and when we observe them through our telescopes, we see great tendrils of glowing gas, illuminated by the hot young stars nestled within them. These are not dense, crowded places. A cubic centimeter of a nebula might contain only a handful of atoms, yet across millions of miles, these diffuse gatherings carry enough material to birth entire solar systems. The density varies wildly from place to place. Some regions are nearly perfect vacuums, while others, by the standards of interstellar space, are positively crowded, dense enough that a grain of dust might rarely collide with another grain, separated by distances that seem impossibly vast by terrestrial standards, yet intimate in the context of the galaxy as a whole. And the dance continues still. The interstellar medium is not static. It ebbs and flows with the radiation from nearby stars, with the shock waves from supernovae, with the gentle push of stellar winds. New atoms are constantly being added as stars reach the end of their lives and return their material back to the cosmos. Heavy elements created deep within stellar cores are cast outward, enriching the interstellar medium with the building blocks of new worlds. The iron that flows through your blood, the calcium that forms your bones, the oxygen that fills your lungs, all were born in the hearts of stars now long dead, then scattered through the interstellar medium, and finally gathered again into planets and living things. You are, quite literally, the product of stellar emptiness, organized and animated by the vast patient silence of space. And if we pull back now, if we let our view expand still further, past the neighboring stars and beyond the gossamer streams of interstellar gas, what emerges before us is a structure so immense that it defies easy comprehension. We begin to see the true home of our sun. We see the Milky Way, not as we imagine it from Earth, that bright smear across a winter sky, but as it truly is, a vast rotating disk of stars, containing somewhere between 200 billion and 400 billion of them, perhaps more, each one a sun, each one, potentially, surrounded by its own congregation of worlds, all of them wheeling together in one enormous, slow dance around a central black hole at the galaxy's heart. The disk itself is incomprehensibly thin. If the Milky Way were the size of a dining table, it would be as thin as a sheet of paper. And within this paper, within this gossamer plane, the stars are scattered like grains of salt flung across black cloth. Even now, at this scale, even surrounded by billions of suns, the emptiness between them is almost suffocating. Our sun and Proxima Centauri, the nearest star, are separated by 4.24 light-years. That is the distance light itself would travel in 4 years and 4 months. In our cosmic neighborhood, they are neighbors. They are close. And yet between them lies an expanse so profound that if you were to stand on a world orbiting Proxima, our sun would appear as nothing more than a pale, distant spark. Certainly not bright enough to warm anything, certainly not visible to the naked eye without knowing precisely where to look. Think about that for a moment. The nearest star to us, the single closest neighboring sun in all the galaxy, and it is so far away that its light takes longer than a human childhood to reach us. And there are hundreds of billions of stars arranged throughout the disk, most of them vastly farther away. The average spacing between stars in our galactic neighborhood is perhaps 3 to 4 light-years. 3 or 4 light-years between nearest neighbors. In an entire galaxy, this is not crowding, this is not fullness, this is profound, staggering solitude. When we chart the positions of stars across the galactic disk, when we map them in 3 dimensions, what we discover is that they cluster into spiral arms. The Milky Way is not a simple disk, but a spiral galaxy, with great curved feathers of stars threading outward from the dense core. These arms are not solid structures. They are density waves, places where stars have concentrated slightly more densely than in the voids between them. Even in these arms, the typical distance between stars remains light-years. Even in the densest regions of our galaxy, emptiness dominates. Beyond these spiral arms, between them, lies what astronomers call the galactic disk proper. Here, the star density drops further still. Stars become sparser. The nights, were you to inhabit such a place, would be darker. The nearest sun would be even farther away. And surrounding the entire disk, extending far beyond it, orbits a halo of ancient stars and globular clusters. These are the outer suburbs of the galaxy. Outposts of light in depths of darkness so complete that the night would be almost absolute. The galactic disk itself rotates, but not as a solid object rotates. The inner regions complete one revolution around the core in perhaps 250 million years. The outer regions, where our sun resides, roughly 26,000 light-years from the galactic center, take much longer. Our sun and all the stars near it are locked in an orbit that takes about 230 million years to complete. That is the galactic year. By the time our solar system completes one journey around the Milky Way's center, continents on Earth have drifted across the surface, species have evolved and vanished, and civilizations have risen and fallen countless times. The stars wheel slowly. The emptiness around them remains constant. What becomes clear as we contemplate the galaxy at this scale is that emptiness is not a flaw in the cosmos. It is not a feature to be lamented or overcome. It is the fundamental condition of existence. Stars exist not despite the void, but because of it. They are islands of concentrated matter separated by immensity, and between these islands, in the voids both near and far, galaxies themselves are distributed. The Milky Way itself, this enormous spiral disk containing hundreds of billions of stars, is itself just one of perhaps 2 trillion galaxies in the observable universe. 2 trillion vast structures, each one separated from the others by mind-bending distances measured in millions of light-years. Consider what this means for a moment. Our Sun is utterly unremarkable. It is a medium-sized yellow star, neither particularly hot nor cold, neither particularly massive nor small. There are billions upon billions like it. Our galaxy is vast beyond easy comprehension, containing stars enough to outnumber all the grains of sand on all the beaches of Earth many times over. And yet our galaxy is, itself, utterly average in the context of the broader cosmos. A typical spiral, medium-sized, unremarkable. One among 2 trillion others, all of them separated by oceans of void, all of them alone in ways that seem almost incomprehensible when you truly let the scale sink in. This is what the universe looks like when you zoom out to the galactic scale. Not fullness, not crowding, not a universe teeming with visible matter and substance. Rather, a universe of structures separated by emptiness, points of light suspended in darkness, islands in an infinite sea. And yet, this emptiness is not random. It is not the result of some accident or careless arrangement. There is a force at work here, invisible and patient, that has been shaping the universe since the very beginning. That force is gravity. And to understand why space remains so profoundly hollow, you must understand what gravity does, and perhaps more importantly, what it chooses not to do. Imagine, for a moment, that all the matter in the universe, every atom, every star, every wisp of gas, began in perfect equilibrium, spread evenly throughout space, like an infinite, featureless fog, absolutely uniform, perfectly balanced. In theory, such a universe would remain that way forever, each particle held equally distant from every other, nothing ever drawn closer, nothing ever pushed away. But the universe has never been content with such uniformity, and gravity is why. Gravity is the ultimate architect of emptiness. It is the tool that creates both abundance and void. When 2 objects possess mass, they exert a pull on one another, a gentle, relentless attraction that grows stronger the closer they come. This is not mysterious or magical, but rather a fundamental conversation between matter and space itself. And this conversation has a peculiar consequence. Instead of distributing matter evenly everywhere, gravity does the opposite. It collects matter, it gathers it, it draws it together into clumps. Think of what happens when matter begins to cluster. A handful of atoms draws others near. Those atoms attract more atoms, and more still. Slowly, inevitably, gravity wins its patient game. A small concentration becomes larger. A larger concentration becomes denser. And as it becomes denser, its gravitational pull grows ever stronger, pulling in even more material from the surroundings. This is the essence of how stars are born, how galaxies form, how any structure whatsoever emerges from the primordial simplicity of the early universe. But here is the remarkable truth that emerges from this process. For every place where matter clumps together, every star, every planet, every dense knot of gas and dust, there must be a place where it does not, where it has been drawn away, where it has been depleted. The act of gathering in one location necessarily creates emptiness in another. Gravity does not fill space uniformly. It concentrates, it evacuates, it creates density here by creating void there. This is not a flaw in the system. This is the system itself, working precisely as it must. When a star forms, collapsing under its own weight until nuclear fusion ignites in its core, the material that becomes that star is no longer distributed across a vast cloud. It is concentrated into one brilliant point. The space surrounding that formation becomes correspondingly emptier. The more that gravity gathers somewhere, the more dramatically it empties somewhere else. And this principle repeats on every scale. As galaxies form, the regions between them grow more sparsely populated. As galaxy clusters coalesce, the cosmic voids between them expand and deepen. Consider the mathematics of this, if only for a moment. The gravitational force between two objects depends on their mass and the distance between them. It diminishes with the square of that distance. This means that as things move further apart, the pull between them weakens very rapidly indeed. Imagine two stars separated by a light year. The gravitational attraction between them is vanishingly small. Now imagine them separated by 10 light years. The force drops by 100 times. 100 light years apart, the force has become so negligible as to be almost completely irrelevant. Gravity simply cannot hold distant things together. It lacks the strength, and so distant things remain distant. They drift, they stay apart, and the emptiness between them persists. This is why, perhaps, the universe resembles a kind of cosmic foam, or a web, with strands and voids. The matter that exists congregates along filaments, clustering together in dense nodes of galaxies and galaxy clusters, connected by thin threads of lesser density, while vast regions between them remain almost entirely devoid of ordinary matter. Gravity has done this work over billions of years, sorting, arranging, creating architecture through the simple act of drawing together what it can hold. Yet gravity also understands restraint. It knows when it cannot work. When objects are sufficiently distant, when the masses are not sufficiently large, when time has not yet passed for accumulation to occur, gravity accepts its limitations. It does not artificially create structure where none can sustain itself. This is perhaps the deepest secret of cosmic emptiness. The void is not empty because gravity has failed. The void exists because gravity has succeeded. By pulling matter together so effectively where conditions allow, gravity has left the vast majority of space magnificently, almost completely alone. As we drift now through layer after layer of deepening darkness, the familiar stars of our own galaxy begin to fade behind us, their light dimming to memory. The Milky Way itself, that grand spiral home we have traveled outward from, becomes a distant spiral of pale luminescence, then a coin-sized gleam, then barely distinguishable from the background night. And here, in this incomprehensible gulf between islands of light, we encounter what many astronomers now believe to be the universe's most profound architecture, the vast cosmic voids, those empty territories that stretch for hundreds of millions of light years, punctuated only at their edges by walls and filaments, where galaxies cluster together like frost patterns on winter glass. These cosmic voids are not the near silence we found in interstellar space. This is something far more extreme. Imagine traveling for 1,000,000 years in any direction and encountering, perhaps, a single small galaxy. Imagine the isolation of that journey, the utter absence of companions in the dark. A typical void might measure 200 million light-years across, and within it, galaxies are so sparsely distributed that the average distance between them is nearly 10 million light-years. Consider that number. Let it settle into your mind. 10 million light-years. Light itself, racing at its inconceivable speed, would require 10 million years to cross from one galaxy to its nearest neighbor. What is perhaps most striking about these voids is not their existence, but what surrounds them. Because space does not distribute itself randomly across the cosmos. Instead, galaxies cluster and align along filaments, vast, gossamer threads of matter that form the skeleton of the universe itself. These filaments are typically less than 5% as dense as they appear to be on average, yet compared to the voids around them, they are almost crowded. Imagine the contrast: an empty room and then a corner where shadows have gathered just slightly more thickly than elsewhere, yet still mostly shadow. These filaments arc through space like the walls of a great cosmic honeycomb, and the voids between them are the cells, each one a cathedral of emptiness so complete that a mind traveling through it would find itself in solitude beyond almost any earthly comparison. Galaxies string themselves along these filaments in clusters and superclusters, vast gravitational associations that formed in the early universe when matter was drawn together by gravity's patient work. Our own galaxy belongs to such a structure, the Local Group, which is itself part of a larger assembly called the Virgo supercluster, which traces one thin thread in this cosmic web. And between these threads lies nothing. Not nothing in the way we understand nothing in ordinary experience, but a statistical emptiness so profound that if you were to travel through one of these voids and arrive at another galaxy after 10 million years, you would be meeting your nearest neighbor. What draws galaxies to arrange themselves this way, rather than scattering evenly across the expanding universe? Gravity, working in concert with the laws of physics that govern how matter behaves on the largest scales, has carved this architecture from what would otherwise be an almost uniform distribution of mass. The filaments themselves are composed not merely of galaxies, but also of diffuse gas and mysterious dark matter, that invisible substance which makes up roughly 85% of all matter in the universe, yet whose nature remains one of astronomy's deepest unsolved puzzles. Dark matter traces the filaments invisibly, binding galaxies to these cosmic threads through gravitational threads we can measure but not directly observe. The galaxies we see are like bright beads strung along an invisible wire, clustered most densely where the dark matter concentration is greatest. As our perspective expands yet further, we begin to perceive the universe not as a random scatter of islands in an empty sea, but as something more complex, a structure with genuine topology, with walls and filaments and vast hollow spaces between them. This is the cosmic web, and it is perhaps one of the most beautiful discoveries modern cosmology has afforded us. The universe is not uniformly empty, nor is it crowded. It is, instead, almost entirely empty, except along these specific threads where matter has accumulated through billions of years of gravitational attraction. Here in the voids between galaxies, the density of matter approaches something almost incomprehensible in its thinness. In a region of space the size of a sphere encompassing our entire solar system, you might find a few atoms, if any at all. The pressure is infinitesimal. The darkness is absolute. The silence, if sound could propagate through such emptiness, would be a silence never broken by even the faintest whisper. Yet these voids are not entirely without consequence. They shape the expansion of the universe itself, influencing how space stretches and how galaxies move apart from one another. Some physicists suggest that the structure of these cosmic voids may hold clues to understanding dark energy, that mysterious force which appears to be accelerating the universe's expansion, pushing all galaxies apart ever more rapidly as time progresses. The voids themselves are ancient. Their large-scale structure was established early in cosmic history, when the universe was far younger and denser than it is now. Small quantum fluctuations in the early universe, stretched across vast distances during the period of cosmic inflation, created subtle differences in density from place to place. Gravity amplified these differences, drawing matter together in some regions and leaving other regions relatively empty. As the universe expanded, these initial differences were stretched outward, transformed over billions of years into the cosmic web we now observe. The voids grew larger, the filaments grew more pronounced. The universe, paradoxically, became simultaneously emptier and more structured. And as we rest here in the imagination, floating through one of these immense voids, we might ask, what does it mean for space to be empty on such a scale, and yet for structure to emerge from that emptiness? How do filaments form from the near-perfect uniformity of the early universe? These are questions that physicists continue to explore, watching the motions of galaxies and the light of distant supernovae to understand the geometry of this cosmic architecture. And yet, as our instruments have grown more precise, as our telescopes have learned to measure the faint light of distant galaxies and the subtle tug of gravity across the cosmic void, astronomers have encountered something unexpected in all this emptiness. A mystery, really, something that doesn't quite fit the picture we've been describing. When they calculate how much the universe should weigh, all the stars, all the gas clouds, all the dust and planets and black holes we can see or infer, and then they measure how gravity actually behaves, how it bends light and pulls galaxies around each other, the numbers don't match. There's far more gravitational pull than the visible matter can account for. It's as if the universe contains some invisible substance we cannot directly observe, something that exerts a gravitational influence but sends no light our way, reflects no light, absorbs no light. Astronomers call this dark matter. Picture, if you will, a vast invisible scaffolding throughout space. Not empty space at all, in the sense we've been imagining it. Rather, a framework of matter we have yet to fully understand, woven throughout the cosmic web, holding galaxies together with a grip far stronger than their visible stars and gas should possess. We know it's there because we can feel its effects. We can measure its weight by watching how galaxies move, how they spiral, how clusters hold together. But what it actually is, whether it's particles we haven't detected yet, or some exotic form of matter from the early universe, or something else entirely, remains one of the great unsolved questions of physics. And the mystery deepens. In the late 1990s, astronomers made an observation even more bewildering. They discovered that the expansion of the universe itself is accelerating. In the billions of years since the Big Bang, space has not been expanding at a steady rate, slowing perhaps under the pull of gravity. Instead, it's speeding up. Galaxies are flying apart from each other, faster and faster. Some force or property of the empty universe itself, is pushing everything outward. They named it dark energy. Unlike dark matter, which clusters and clumps and shapes structure, dark energy seems to be smoothly distributed through all of space. It's not pulling galaxies together, it's pulling them apart, gently, relentlessly, stretching the very fabric of space-time itself. We don't know what it is. It might be the energy of the vacuum itself, a property of empty space that we're only beginning to glimpse. It might be something far stranger, something that doesn't fit neatly into our current understanding of physics at all. But its effects are real and measurable, and it comprises the vast majority of the universe's total energy content. So consider what this means for our journey through the emptiness. The space we've been traveling through, between stars, between galaxies, through the cosmic voids, isn't truly empty at all. It's permeated by dark matter, a ghostly presence holding structure in place, and it's suffused with dark energy. a mysterious force of expansion that's relentlessly stretching the distance between all things. The universe is simultaneously being shaped by invisible gravity and pushed outward by invisible force. The emptiness we've been exploring is actually filled with influences we're only beginning to comprehend. These are still theoretical frameworks, mind you. Dark matter and dark energy exist in our models, in our equations, in the predictions that match what we observe, but we haven't held them in our hands. We haven't trapped them in a laboratory. They remain, for now, concepts that explain what we see, while reminding us of how much we don't yet understand. Future generations of physicists may discover they were on the right track, or they may find that nature is even stranger and more wonderful than we've imagined. That's the beauty of science unfolding, always provisional, always open to revision as our tools become sharper and our knowledge deepens. But the point that settles gently into understanding as we drift through this darkness is this. The universe is fundamentally not what it appears. What looks like nothing is actually something. What seems like absence is presence in disguise. And what we can see, all the stars and galaxies and dust clouds we've described throughout this long journey, comprises only about 5% of what's actually there. The rest is hidden from direct view, working silently to shape the vast structures around us, to orchestrate the dance of galaxies, to weave the cosmic web we inhabit. The emptiness, then, is not passive. It's not merely the absence of things. It's an active participant in the universe's unfolding. It holds and shapes and pushes. And in that reminder that even the void itself is alive with influence, even the space between stars is full of mystery, we find ourselves drawn deeper into the profound quiet of it all. If we trace this emptiness backward through time, we find ourselves asking a question that physicists have wrestled with for nearly a century now. Where did all this nothing come from? The answer lies in a moment so distant, so compressed, so impossibly hot and dense that it resists easy description. Imagine, if you will, not the vast and hollow universe we inhabit now, but its opposite, a state so tightly packed that all the matter and energy we can observe across billions of light years was crushed into a space smaller than the smallest grain of sand you might hold in your hand. This is the early universe, and within it lived the seeds of all this emptiness. In those first fractions of a second after the beginning, the universe exploded outward in what cosmologists call the Big Bang, though explosion is perhaps too gentle a word for what occurred. The expansion was not matter spreading through empty space, but rather space itself tearing open, stretching, unfurling like the most patient bloom imaginable. And as it did, something remarkable happened. The density of that primordial material began to thin. What had been infinitely packed became merely compressed. What was compressed became sparse. What became sparse eventually became the gossamer thing we now observe, stretched across a universe so old that 13.8 billion years have passed since that moment of genesis. This expansion never stopped. Even now, at this very moment, space continues its patient work of stretching, pulling every galaxy away from every other galaxy, widening the chasms between them. And as space expands, the matter within it is distributed across ever greater volumes. Imagine taking the same amount of flour you use to make a small cake, but then gradually pouring it across an entire continent over the span of billions of years. That is something of what has happened to the matter in our universe. The stuff that once was almost impossibly crowded has been thinned and thinned and thinned again across the cosmic expanse, until what remains is mostly absence. In the very beginning, the early universe was, in its own way, almost entirely full. The temperatures were so extreme that individual atoms could not hold together. Even light itself was trapped, scattered endlessly by the dense fog of particles that filled every possible space. But within the first 380,000 years, a blink in cosmic time, something shifted. The universe had expanded enough, cooled enough, that electrons and nuclei could finally bind together to form neutral atoms. Light, for the first time, could travel freely. Transparency emerged from opacity, and suddenly the universe became, in a sense, less full and more empty all at once. And yet within that thinning material lay something crucial: tiny variations in density. Some regions had slightly more matter than others, imperceptible differences that would take on tremendous significance over billions of years. Gravity, that patient sculptor, began its slow work of pulling slightly denser regions together, while the expanding space between them grew larger and larger. The result was a kind of cosmic sorting, a gradual separation of matter into islands of relative abundance surrounded by increasingly vast oceans of near-nothing. As the universe aged, these density variations grew more pronounced. Galaxies formed from the slightly denser clouds. Stars ignited within those galaxies from the slightly denser regions of gas and dust. Planets coalesced around stars from the slightly denser swirls of material. And all the while, the background expansion continued its inexorable work, stretching space itself, widening the gaps, deepening the quiet. What was once a soup of particles became sparse clouds. Sparse clouds became isolated stars. Isolated stars became the vast archipelago of galaxies we see today, each one a small cluster of light, in a universe that grows emptier with each passing year. When we look at the night sky now and see nothing but darkness between the distant points of light, we are witnessing the cumulative effect of billions of years of expansion. The universe is not getting crowded. It is getting lonelier. The average distance between galaxies increases with each moment that passes. Gravity tries to hold certain clusters together, creating the filaments and walls of the cosmic web, those gossamer strands of galaxies that trace the boundaries of cosmic voids. But even gravity cannot counteract the expansion. It can only slow it, concentrate matter locally, create pockets of relative richness in an overall landscape that grows steadily more spare. This expansion was not uniform, we should note. In some regions, gravity was strong enough to overpower the outward rush, creating structures that remained tightly bound even as space around them stretched. These became the first galaxies, and they were held together not by their own power alone, but by the mysterious substance we call dark matter, whose nature remains one of physics's deepest unsolved questions. Dark matter outweighs visible matter by a factor of about 5 or 6 to 1, yet it reveals itself only through its gravitational influence. It is there, scattered throughout the universe, yet utterly invisible, shaping the fate of galaxies while remaining hidden from our direct observation. So when we consider why space is almost entirely empty now, we must trace that emptiness back to its origin, in an act of expansion so gradual, so relentless, that it has turned what was once incomprehensibly dense into what is now almost incomprehensibly sparse. 13.8 billion years of stretching. 13.8 billion years of matter being pulled apart, of density being diluted, of silence deepening. This is not the result of matter dispersing through space, but of space itself becoming vastly larger, while the matter within it remains relatively constant. The universe did not become empty because things scattered. It became empty because the space between things never stopped growing. And here, in our current era, we exist in the aftermath of all that stretching. We live in the twilight of density, in the long, slow epoch where the universe's expansion continues to dominate, where the distances between things grow longer with each passing year. The stars that are nearby by cosmic standards will one day be impossible to reach. Civilizations a trillion years in the future may look out at a universe so thin, so sparse, so divorced from its own origins, that they would hardly recognize it as the same cosmos from which all things descended. We are living in what cosmologists sometimes call the old universe, an epoch so far removed from the Big Bang that the imprint of those early, denser times has been nearly erased by the patient work of expansion. Now, all of this, the interstellar gulfs, the cosmic voids stretching across billions of light years, the thin filaments of galaxies threading through darkness, it exists in a scale so far beyond our daily experience that the mind struggles to hold it. And so it may help, as we drift through these numbers and distances, to find a way to picture this emptiness using something more familiar, something we can almost touch. Imagine, if you will, an ocean, not a lake or a bay, but one of Earth's true oceans, the Pacific, perhaps, or the Atlantic, vast enough that its horizon dissolves into mist, deep enough that sunlight fails somewhere far below. Now imagine that ocean divided into grains of sand, not a beach's worth of sand, but the entire ocean reduced down, grain by grain, into individual particles. Each grain would represent a star or a significant cluster of matter. And if you were to take just one handful of those sand grains, one single handful, and scatter them across that entire ocean's surface, you would begin to approach the actual density of the universe. The universe, in other words, is that ocean, and we are the scattered handful, not crowded, not pressing against one another, simply there, separated by immensity. Let's think of it another way, because the human mind learns through layering and repetition, and the ocean metaphor, while beautiful, may need a companion. Consider a library, not a small town library with a few thousand books, but the greatest library ever built. Imagine it so vast that it would take a lifetime to walk through all its corridors. Now imagine that every book in that library represents a single star. Every shelf, every wall, every wing and gallery contains books. It seems crowded, doesn't it? A library full of books feels full. It feels dense with content. But now imagine that same library, reduced. Imagine that instead of filling an entire city block, this library is the size of a single grain of sand. All those thousands or millions of books, all those stars, compressed into something invisible to your eye. That is how the universe is when you account for the sheer volume of space. The abundance feels impossible because the stage is so incomprehensibly large. There is another comparison that astronomers sometimes return to, and it involves a thought experiment about baseball stadiums. If you were to place every atom in your entire body, the trillions upon trillions of particles that compose you, it would be equivalent to the number of stars in the observable universe. That is to say, there are as many stars as there are atoms in you. Now take that number and imagine it spread across a volume so vast that if every atom were a star and each star system spanned billions of miles, there would still be almost nothing touching anything else. The stadium idea suggests that if you took all the atoms in a single grain of sand and converted them into stars, there would still be room between them, room measured in millions of miles. These comparisons are not exact, of course. Mathematics, in its precision, always exceeds the metaphor. But they serve a gentle purpose as we contemplate these distances. They allow the mind to relax slightly into the concept rather than recoil from it. Because when you hear that the average distance between stars in our galactic neighborhood is measured in light years, the number becomes abstract. It becomes a symbol rather than a thing. But when you hear that the universe is like an ocean with a handful of sand scattered across it, something shifts. The vastness becomes almost palpable. You can almost feel the quiet. And this quietness, this sparseness, it is not a flaw in the universe. It is not an accident or a mistake. The emptiness, in fact, is a prerequisite. Imagine if space were not empty. Imagine if the universe were a thick, dense medium, like molasses or gelatin. What would happen to light? How would it travel? How would it bend around massive objects to create the structures we see? A universe packed densely with matter would be a universe of darkness and collision, where nothing could orbit anything else for long, where no stable systems could form. The emptiness is what allows for order. The emptiness is what allows for us. When you lie in darkness and think about the space above, the vast, hollow, almost nothing that stretches from your skin to the edge of comprehension, you are resting within a universe that is fundamentally, almost overwhelmingly alone. And in that aloneness, in that sparse arrangement of matter, scattered like thoughts through an endless mind, there is something strangely soothing. The universe is not crowded, it is not pressing down, it is quiet, and it is vast, and it contains us as gently as an ocean contains a grain of sand. And here is where we arrive at perhaps the strangest paradox of all, that this emptiness, this profound sparseness we have traced across billions of light years, is not a curse, but a gift. It is, in fact, the very foundation upon which everything we know and cherish has been able to unfold. Consider for a moment what would happen if space were not empty, if the universe were densely packed with matter from edge to edge, from the smallest corner to the grandest expanse. Nothing could move, light could not travel, gravity could not shape things into form. You could not exist, because the atoms that make you would be locked in an eternal, motionless embrace with every other atom around them, unable to vibrate, unable to dance, unable to create the chemistry of thought and breath and consciousness. Space's emptiness is not negligence, it is permission. It is the empty theatre stage that allows the play to begin. Light needs that emptiness to journey. Every photon that left the sun this morning and travelled through the solar system to warm your face yesterday required a clear path, vacuum through which to move unimpeded. If space were filled with matter, light would scatter and dissipate almost instantly, absorbed and re-emitted in a chaos of interactions. The universe would be opaque to itself. Stars would not be able to see stars. Galaxies would not shine across the darkness to distant observers. And here on this small planet, we would not be able to look up at night and perceive the cosmos at all. The emptiness allows light to be light. In that same emptiness, structure becomes possible. Matter can gather. Gravity, working across those vast hollow distances, pulls wisps of gas together over millions of years until they ignite, and a star is born. That concentration of matter in the void is what makes a star possible. Without the emptiness to pull away from, matter has nowhere to go, nothing to do. The sparseness creates valleys and slopes in space itself, gentle gravitational hills down which material can flow and collect. Imagine a vast, dark ocean with islands of light emerging from the silence. Those islands exist precisely because the ocean is so vast, so empty, so quiet. Without the ocean, the islands would be meaningless. Without the emptiness, matter would have no purpose, no direction, no way to become something distinct and particular. And from that structure, those stars and planets formed in the void, life has found a way to emerge. It is remarkable, almost mysterious, that beings capable of consciousness, of wonder, of asking questions about the nature of the universe itself, arose in pockets of ordinary matter scattered across an almost incomprehensibly hollow cosmos. But perhaps it is not so strange after all. Life requires stability. It requires a habitable zone, a planet at just the right distance from a star, bathed in just enough light and heat. That planet needed space around it, emptiness to orbit within, freedom of motion, protection from other worlds' gravity. Without the vast empty stretches between planetary bodies, collisions would be constant and frequent. Worlds would be knocked from their courses. Atmospheres would be stripped away by gravitational encounters. Life would have no chance to root and grow. The emptiness, then, is not hostile. It is generative. It is full of potential precisely because it is empty of obstruction. When we speak of the sparseness of space, we are not describing a barren wasteland. We are describing a canvas. We are describing the silence in which music can be heard. The silence that every musician understands is not the absence of sound, but the necessary counterpart to it. The space between notes that gives melody its shape and meaning. There is something almost tender in this realization. The universe, in its vastness and emptiness, created the conditions for you to exist, for us to exist. The thinness of the interstellar medium, the loneliness of planets orbiting distant stars, the tremendous gaps between galaxies stretching across billions of light years, these are not flaws in creation. They are preconditions. They are the gentle, vast architecture upon which smaller, warmer, more intimate things could come to be. The cosmos built itself this way, sparsely, to allow for the dense complexity of life. And perhaps in understanding this, in letting this thought settle into your awareness as you drift towards sleep, there is a kind of peace to be found. We are made of the remnants of stars. We live on a small world held gently in its orbit by the balance of emptiness and gravity. We are surrounded, always, by vast silence. And that silence is not lonely. It is simply the deep breath the universe takes between heartbeats. It is the pause that makes consciousness possible. And so we arrive, once again, at the place where we began, the vast, patient darkness between the stars. The profound silence that dwells not in absence, but in the gentle presence of everything that has ever been scattered so impossibly thin across the fabric of creation. Imagine drifting now, as we did at the start, through that great gulf between our sun and its nearest neighbor, Proxima Centauri. 4 light-years of darkness, 4 light-years of the most exquisite emptiness. The solar wind that once brushed against your invisible vessel has long since faded into an even deeper hush. The occasional stray photon from a distant star touches your cheek like a whisper from someone you have never met, and likely never will. All that you have learned tonight, the vast scales, the mathematics of distance, the thinness of matter strewn across incomprehensible spans, the gravity that pulled it here and there into rare islands of density, all of it becomes at last a kind of answer to a question you may not have known you were asking. Why is the universe so quiet? Why is there so much room? The answer, perhaps, is not that space is empty at all, but rather that it is full of permission. Permission for light to travel, permission for planets to spin in their careful orbits, permission for the delicate chemistry of carbon and oxygen and nitrogen to assemble itself into beings capable of wondering about the very emptiness that made their existence possible. There is a peculiar restfulness in understanding this, in realizing that what feels like absence is, in truth, the greatest abundance, the abundance of freedom, the abundance of possibility. Without this vast hollow architecture, without the eons of space separating matter into islands of complexity, there would be no stars, no planets, no quiet nights beneath them where you might lie and consider their light. The emptiness is not a mistake or an accident. It is the essential foundation upon which all structure rests. It is the canvas upon which the universe has painted every color, every form, every story that has ever unfolded. And in this moment, drifting still in the darkness between suns, you might notice something unexpected beginning to happen inside you, a settling, a release of the tension you carry in the small, brief days of living in one particular time, in one particular body, in one particular corner of this vast and nearly empty realm. The weight of urgency begins to lighten. The nagging sense that there is something you should be doing, somewhere you should be going, dissolves into the immensity that surrounds all things equally. Out here, in the spaces between, there is only being, only the slow turn of galaxies, only the patient, measured expansion of everything away from everything else, stretching the emptiness ever thinner, ever gentler. What would it feel like to let yourself expand into that same spaciousness? To imagine your own small consciousness as one more particle, one more whisper of presence in the great hollow cathedral of the cosmos. Nothing is required of you but to exist, as you do, as each star does, as the dust between the stars does. Your presence here, in this quiet moment, is enough. Your awareness of the vastness is enough. The simple fact that you are conscious enough to marvel at emptiness itself, that is more than enough. That is everything. The silence presses gently around you now, and it is no longer frightening or isolating. It becomes instead a kind of embrace. The very absence of sound becomes a presence of its own, a presence of peace, of rest, of completion. All the light you have ever seen has traveled through this emptiness to reach you. All the atoms that make up your body were once forged in the heart of stars that died long ago, scattered across the vast hollows of space and drawn together again by gravity into the particular miracle that is you. You are not separate from the emptiness. You are woven from it. You are made of the same stardust that drifts between the stars, arranged into a form capable of contemplating its own origins. And so you rest now, in the knowledge of this truth, in the gentle acceptance that the universe is far larger than any single concern, any single worry, any single moment of urgency or fear. The emptiness that surrounds you, that surrounds all things, is not something to be afraid of. It is something to surrender into. It is the breathing room of existence itself, the space where all transformation takes place, the silence in which all true things are spoken. Let your breath become as slow and patient as the expansion of the universe. Let your thoughts grow as sparse and scattered as matter across the cosmic void. There is nowhere else you need to be. There is nothing else you need to do. Here, in the darkness, drifting between the stars with no need to arrive anywhere, you are finally, completely at home. The vastness that seemed so lonely when we began our journey together now feels like an old friend, a gentle, eternal presence that has always been waiting for you to recognize it. And in this recognition, in this moment of understanding the true nature of the emptiness that surrounds and sustains all life, all consciousness, all light, you find something unexpected, peace, a peace so profound, so complete, that sleep arrives not as an absence, but as a homecoming to that same vast and patient silence from which you came, and into which you now gently drift.